Hi students, welcome to my channel Chemistry by PNSK. In this class, we are discussing about the graphs. Okay, for what we are discussing the graphs here? We are discussing the graphs here about psi, nothing but the wave function versus radius. Wave function versus radius or okay. In some books it is representing as a capital R. Okay, but here we are representing wave function is psi. Okay, why we need to representing the graphs here? Because in previous class we are discussing about the shapes of the orbitals. Okay, at there we are observing one thing, nothing but nodes, angular nodes and radial nodes. Nodes, angular nodes and radial nodes. What are the nodes where the probability of finding the electron is 0, which is nothing but the nodes. In nodes there are two types. Okay, one is angular nodes and another one is radial nodes. Radial nodes. And we also provide formulas for finding the nodes are nothing but total number of nodes is n minus 1. For finding the radial nodes, the formula is n minus L minus 1 and angular nodes are nothing but the L. Okay, here angular nodes are depending on only L values, but coming to radial nodes depending on both N values and L values. Okay. Let us draw the graph for 1s orbital. This is a 1s. On x-axis we are taking the r. Here r is nothing but distance from nucleus to where the electron it is. Okay, distance of the electron from the nucleus. Psi is a wave function on y-axis. Then the graph will be like this. The graph will be like this. Because if you take the radial nodes for 1s orbital, the formula is n minus L minus 1. What is the n here? 1. Minus L value for s orbital is 0. Minus 1. That is plus 1 minus cancel, it become 0. So there is no radial nodes. That's why here we do not represent any node. Okay. Let us come to 2s. This is a 2s. The graph plot between, okay, wait. Let us take, this is the graph for 1s. Okay, let us take the graph for 2s. This is a 2s. For 2s, we have to find the radial nodes. That formula is n minus L minus 1. That is, a radial nodes equal to, n value here is 2. Okay, L value for s orbital is 0 minus 1. That is, one radial node is observed here. By using these radial nodes, if you plot the graph, on x-axis we are taking the r, on y-axis we are taking the wave function. The graph will be like this. Okay, here we are observing the node. This node is nothing but the radial node. Okay, this is a positive part and this is a negative part. Understand? Next. If we plot the graph for 3s, the graph will be on x-axis you are taking the radius, on y-axis if you are taking the wave function, the graph will be like this. Here two nodes are observed. Okay, two nodes are observed. For 3s, radial nodes are n minus L minus 1, that is here n is a 3 minus L value 0 minus 1, that is 2. two radial nodes are observed. This is a 1 and this is a 2. Okay. By this, you are observing one thing, that is negative values are observed here. This is the negative part, this is the positive part, and this also positive part. Positive parts and negative parts are observed here. In 1s orbital, there is 0 nodes. Why? Because if you take this is the nucleus. If you take the 1s orbital, the finding the probability of electron is very difficult because there is no nodes. Okay. If you take the 2s orbital, this is the nucleus. This is the 1s. This is the 2s. Between the 1s and 2s, the gap is there. Okay, between the all this thing is a 2s. Okay, this is a cloud of 2s. But it is a 1s, this is a 2s. Between 1s and 2s, there is a gap is finding. That gap is nothing but the node. Here, finding the probability of electron is 0. Okay, coming to 3s, this is the nucleus. Around the nucleus, it is 1s, it is the 2s, and this is the 3s. Here between 1 and 2, one radial node is there. Okay, between 2s and 3s, one more radial node is there. That's why there are 2 radial nodes observed in the 3s. The graph will be plotted like this. Okay, this is about the s orbital wave function versus radius of electron from the nucleus graphs. Let us take the p orbitals. Okay, before going to showing the p orbital graphs, I will show the visible view of the orbital cloud. Students, observe here. This is the 1s, this is the 2s, and this is the 3s orbital. Here 1s, there is no finding of nodes. Let us come to 2s. Here finding of node is 1. This is a clear representation for the 2s. Okay. But coming to 3s, this is a 1 and this is a 1. There are finally 2 radial nodes are there. This is the representation for the radial nodes of 1s, 2s and 3s. One thing you are observing that as the number of orbitals increasing, size of the s orbital increasing. Okay. This is a visual representation for the taking graphs. Okay. Have you got? Students, let's take the graphs for p orbitals. If you take the 2p orbital, okay, the graph is on x-axis we are taking the r and on y-axis taking the wave function. Okay, wave function. The graph will be, this is the nucleus or center. This is the nucleus or center. The graph will be like this. The graph will be like this. Ma'am, why you are writing the graph from nucleus, ma'am? Because in previously we are seeing the s orbitals. For s orbitals, psi value equal to 0. That's why the graphs are not starting from nucleus. For p orbital, psi value not equal to 0. That's why the graphs are starting from nucleus. Here for 2p we are not finding any radial nodes. That's why we are not representing any nodes here. Okay. For 3p, this is on x-axis we are taking the radius and on y-axis we are taking the wave function. The graph will be like this. Here we are finding the one node, nothing but the radial node. This is a positive part and this is the negative part. The peak where it is a maximum. Okay. For p orbitals, calculate the radial nodes, nothing but for 3p orbital, n is 3, L values is 1 and minus 1, that equal to 3 minus 2 equal to 1. Okay. This 1 is nothing but this radial node. This graph is not only for 3p orbital. Okay. 3p orbital, 4d and 5f also. In all these we are finding one radial node. This graph not only for 2p, it is for 2p, 3d and 4f. Okay, like this. Next, for 5p, we are finding the radial nodes are 5 minus, for p orbital it is 1 minus 1, that is equal to 5 minus 2. Okay, that is nothing but the 3. Let's plot the graph for 5p orbital. The graph will be 3 nodes are observed. Okay, that is like this. Here, this is not touching the axis. Okay, this is a one radial node, this is a one radial node, and this is a another radial node. Likewise, while increasing the graphs, the peak distance is decreased. Do you observe that? This is the first one, this is the second one, and this is the third one. Okay. Why we are observing this difference? Because this is the nucleus. As the number of orbitals increasing from nucleus to outermost shell, distance increasing. Okay, that difference is shown here. Okay, then peaks are like here. Next, for p orbital, if you take on x-axis, the xy, the yz are the nodal planes, nothing but the angular nodes. I will show you the visual representation. Students, see, this is the 2p orbital, this is the 3p orbital, and this is the 4p orbital. As usual for 2p orbital, nodes are 0. That's why we cannot represent any nodes. We cannot show you any nodes. For 3p, there is one node is there. Okay, this is nothing but the node between 2p and 3p. This is the node. At here we are finding at this region of node, finding of electron is 0. Okay, but next, coming to 4p, this is a 4p orbital. Coming to 4p, there are two nodes are found. That is in between 2p and 3p one node, and 3p and 4p one node. Okay, two nodes are there. If you take coming to the angular nodes, if the orbital is in x-axis, remaining zx is the nodal plane. At nodal planes, angular nodes are same. Okay, this is the representation for the nodes. If you observe one more thing also, as the number of orbitals increasing, size increasing. Okay, here 2p is very nearer to the nucleus compared to 3p and 4p. Okay, have you got it? Next, when we are plot the graph for wave function and radius, we are getting the negative parts also. This is the positive part, this is the negative part. To evaluate these graphs from the negative parts, we are taking the graph for probability density versus radius of the electron. Okay, let's see that also. Probability density nothing but psi square. Psi square here, psi square is the probability density of the orbital. Okay, or here in orbital where the region of finding the electron is 95%. Okay, let's plot the graph for 1s. This is a 1s. On x-axis we are taking the radius, on y-axis we are taking the probability density of the electron. Okay, the graph will be like this. Okay, for 2s, we are finding the one radial node, then the graph will be then the graph will be, this is on x-axis r and on y-axis psi square. The graph will be like this. This is the one node. This is one node. Why here we are not taking the negative part? Because if the psi value is minus 2, coming to the psi square, if the psi value is minus 2, coming to the psi square, the value is plus 4. Nothing but multiplication of minus into minus gives plus. Okay. In probability densities, all the graphs are positive graphs. We are not explaining any negative graphs. Remember that. But if we are plotting the graph by using the wave function, at there we are getting the negative parts also. But coming to probability density graphs, we are not finding any negative graphs. Okay. This is for 2s. Coming to 3s, the graph will be like this. On y-axis psi square, on x-axis we are taking the radius. The graph will be like this. Okay, this is one node and this is the one node. Why? Because in 3s we are seeing the two radial nodes. Let's see that also. N minus L minus 1. The n value is 3. L value for s orbital 0 minus 1, that is 2. Okay, we are representing the two nodes. By increasing the nodes, the distance of the peak decreases because the orbital is very far to the nucleus. That's where the distance decreases. This is about the s orbitals. Next, see the p orbital graphs. The graph for 2p, 3d and 4f. For all of these we are representing one graph only, that is because there are only 0 radial nodes are there. That's why the graph will be on x-axis we are taking the radius and on y-axis we are taking the probability density psi square. For p orbital, d orbital, s orbital, the graph starting from nucleus and the graph will be like this. The graph will be like this. For coming to 3p or 4d or 4f, the graph will be like this. The graph will be like this. On x-axis we are taking the radius and on y-axis we are taking the probability density psi. Okay, the maximum of the peak decreases by increasing the nodes. Here we are finding the one radial node, but in 3p one radial node is observed. 4d also, 5f also, sorry, 4f also. Okay, this is a 5f, 4d, 5f. Okay, next, here by using these graphs, in examinations asking the questions are like this. He is mentioning one graph. The graph is this. On y-axis he is taking the psi square and on x-axis he is taking the r. By using this graph he is asking question is finding the orbital, find the orbital with, okay, one angular node and one angular node and two radial nodes. In the question he is asking the orbital which it is belongs to, having one angular node and two radial nodes. Okay. Let's solve the problem. How many angular nodes? 1. That one is nothing but the L. If L equal to 1, the orbital is p orbital. Okay. How many radial nodes are there? 2. What is the formula for radial nodes? N minus L minus 1 equal to 2. Okay. N minus how many L? 1. Minus 1, that equal to 2. N minus 2 equal to 2. N equal to 2 plus 2. N equal to 4. nothing but the orbital is for p. Okay, the orbital is for p. Likewise, in the questions, he is mentioning the graphs and asking like this, or else in some questions, he is not mentioning any graph. By using angular nodes and radial nodes, he is asking the orbital. Okay. Likewise, in the exams, he is asking the questions. See, students, observe the thing. The graphs are very important for the competitive exams like GMains and advanced also. Okay. Thank you. Have a nice day.